Hi there. So this is my video covering our exponential functions unit. So I'm going to start off with a warm-up. These are just some questions. I'm going to evaluate these fractions and radicals and exponents. So we're going to start with the first one here. Firstly, I'm going to subtract. We have a division sign here, so I'm going to subtract all the exponents from their variables. So I have 6, that's going to be squared. X, 2 minus 5 is 3, and y to the 2. Then now that we have this simplified, I have to put the x at the bottom. I can square the 6. It's going to give me 36 y squared over x to the power of 3. So that's just learning exponent laws and being familiar with subtracting these exponents. Now I'm going to take this radical here and put it into exponential form. I have the 3 on the outside of the radical, and so I'm going to reduce it into the radical. So I'm just putting it inside here as a fraction to be 1 over 3. And I'm still going to multiply all of this to the power of 4. So now when we're doing the power with these exponents, we're just going to multiply them. It's going to be 6p to the power of 4 over 3, and that's going to be our final answer. And then lastly, we have this is going to be put into radical form. So for this, I have the 3 over 2 exponent here. I'm going to bring it into a radical. So it's going to be, the 2 would go here, 10y to the power of 3 is 10y to the power of 3. Okay, now we're moving on to these expressions here, which I'm going to simplify. So for the first one, we have a division sign. So again, we're going to cancel out the numbers that we have. We're going to divide these two, the 18 by 2. So we're going to have 4 times the square root of 9 times 6. The 6, we're going to be reducing that as well. So it's going to be 6 to the power of 2. Once we have that, I can group these two together. It's going to be 9 times 36. So just doing that, it's going to give me 324. So now we have 4 times the power of 324, but we want to break this down more. So we're going to take this radical and break it into 3 to the power of 4 times the square root of 4. And then with this 4 now, we can reduce it some more and use an exponent to put to the power of 2. So it's going to be 3 to the power of 4 times 2 to the power of 2. And then using this just with the square root, it's going to cancel out. So our final answer is going to be 3 to the power of 4 times the square root of 2. And then our last one here, we're going to simplify this expression. So I have the division sign. So again, we're going to simplify the exponents. But first I have the outside bracket, which is a multiple of to the power of 4. So we're going to multiply that into the bracket. It's going to give us x 4 over 2, y negative 16 over x to the power of negative 12 over 4 times y to the power of 8. Now that we have our x and y values and we've gotten rid of our brackets, we're going to reduce again and just subtract the exponents. So 4 over 2, I'm just going to simplify that for 2, just make it simpler. And same with the bottom, negative 12 over 4 is going to be negative 3. And then y stays the same as 8. So now we can subtract these from each other. So we have 2 minus -3. It's going to give us x to the power 5 and y power of -18. And we want the 18 to be at the bottom since it's a negative. So our final answer is going to be x to the power 5 over y to the power of 18. So we have 2 minus -3. It's going to give us x to the power 5 and y power of -18. And we want the 18 to be at the bottom since it's a negative. So our final answer is going to be x to the power 5 over y to the power of 18. Okay, so lastly, we're going to look at the application of exponential functions. So I've written a word problem here that we're going to work through. So a house plant starts with a height of 12 centimeters and it grows by 15% each week. Determine how high it would reach after 15 weeks. So for this, we have an exponential growth rate. So whatever our equation is, we're going to add 1 plus the growth rate into the equation. So I've written let h times t, h represents the height. Again, it's going to represent the height of the plant in centimeters. So our equation is going to be h of t equals 12. Since it's 12 centimeters is our starting height. So it's going to be 12 times 1 plus 0.5. 0.5 is the 15% growth rate. And the 1 is the exponential growth. Then it's going to be to the power of t, the time, the number of days, divided by 7, because there's 7 days in 1 week. So we're just going to simplify this. So this is our equation for the problem. So when we're figuring out what t is, we know that t is going to be, we're looking for the growth rate in the span of 15 weeks. So we're doing 15 weeks. It's going to be times 7 days. There's 7 days in a week. Over 1 week, because that's how much we have. So we're doing 15 times 7, which is going to make our t be 105. So this is going to be our t value. We're going to put this back into the equation we made. So the height of 105, our t value, is going to be 12 times 1.15, the growth rate, the power of 105, our t value again, divided by 7, which is 1 week. So when we do this, fill this out, I'm just going to put it in on my calculator. It's going to give us 97.64 centimeters. And so therefore, our plant is going to grow 97.64 centimeters after 15 weeks. So our plant, an easier way to word this is our height of our plant is going to be 97.64 centimeters after 15 weeks. And that's all. Okay, so next I'm going to be graphing some equations. These are exponential functions here. So for the first example, I have 3x to the power of -2 plus 2 that I'm going to graph. Usually our horizontal asymptote would be 0, y equals 0. In this case, our c value here is +2. So that's going to be our horizontal asymptote as I've plotted on the graph here. Okay, so here I'm just plotting down 2 x values which I can then solve for y. So my 2 x values I do when x minus 2 equals 0 and when x minus 2 equals 1. So for both those I just switched it around, so x will equal 2 for this one and x will equal 3 for this. And I'm just plotting it here. Sorry, let me put that. X is 2 and 3. And then now we can plug this back into our original equation to solve for y. So I'll do that here just on the side. And this is going to give us 2, and this will give us 4. So now I have our 2 y values. I'm going to put that into the chart to fill it out. I'm now able to graph it with my 2 points. So I have 2 and 2 here, and 3 and 4 here. Okay, so now I know what my graph looks like, so I'm able to draw it. Here. So again, my sketch never touches the horizontal asymptote, so it's going to go up that way. And then we can also put our domain and range for this. So the domain is going to be every real number, and then for our range, it's going to be y's value of every real number such that y is greater than our horizontal asymptote, which is 2. Okay, so that's going to be our domain and range. So now we're going to graph this one. This is f of x equals 4 minus 2 to the power of 3 minus x. So again, I'm just going to take some x values to plot into the chart so I can fill it out with the y values. So I can do 3 minus x equals 0 for the first one, and 3 minus x equals 1. So when I flip these around, then I can just solve for x equals 3 and x equals 2. So now I have my x values, 2 and 3. And now I can use these to solve for y. So I can just put that here, the power of 3 minus 2. Okay, so it cut out, so I'm going to re-explain this part. So for this part, I have my x values. I'm plotting them into this. I'm just bringing them here so I can be able to solve for the y values. So I have 4 minus 2 to the power of 3 minus 2. That'll give me 2. That's our first plot. And then 4 minus 2 to the power of 3 minus 3 equals 3. So those are our 2 y values here. Now that I have my y values 2 and 3, I can plot it into the graph. So I have 2 and 2 on this plot here, and then 3 and 3 on this plot here. And with the horizontal asymptote, I can see which direction my graph is going, so I can just draw it out at the bottom like I did. And then again, I'm putting my domain and range at the bottom here. My domain is x is every real number, as there's no restrictions. It goes throughout the whole graph. And for my range, it's y is every real number such that y is less than 4, just because, again, 4 is our horizontal asymptote, so it does not touch the number 4. It's everything below. Okay,